In this lesson, we're going to talk about quadratic translations. By the end of this lesson, you should be able to translate a quadratic function and describe the effects of the transformation. We're talking about translations. Translations slide a figure without changing its size and its shape. A parent graph of our quadratic function is y equals x squared. This is a graph that goes through the origin, and it is x squared. It's going to have this same general size and shape. H and k are going to cause the values to translate. H is going to cause it to go left and right, and k is going to cause it to go up and down. When we're talking about how h and k change, remember that we're not including the signs that are in front of it. So, if h is negative, it's going to translate it to the left. If h is positive, it's going to translate it to the right. When you're determining if h is negative or positive, pull h out of the equation. Remember that when we pull it out, it is not a negative. We're not including the minus sign. So that if the minus sign is changed to a plus, that you have a negative value in for h. We'll take a look at an example in just a minute. K is going to move it up or down. Again, if k is negative, you're going to translate it down. If k is positive, you're going to translate it up. Again, pull h and k out of the equation to determine if it is positive or negative. Now, on this following one, A, where it says which parabola is the parent graph, the parent graph is going to be the blue one because that is the one that goes through the origin. And it has the same general shape. Remember that our parent graph is going to be f of x equals x squared. This is the equation of every parent graph of a quadratic function. This is how it starts. Now, how did this change? The change is that it moved to the left 2. So it moved left, no, it moved right, my bad. It moved to the right 2. So our translation that we might see here is f of x equals, or actually let's do this. We have g of x minus 2. So f of x minus 2. So g of x equals f of x minus 2. Alright. We're going to write the equation of the function. So we have f of x equals 2, or f of x equals x squared. This is our parent graph. And it says f of x equal, or g of x equals f of x plus g, where g is 2. So really we have f of x plus 2. So this says take your entire function of f of x. So in this case, f of x is x squared. So take that entire function and add 2 to it. Alright, and we want to describe the effect. So here's our new equation. Our new equation for g of x x squared plus 2, and how it changed is it moved up 2 units. It went up 2. When we're looking at this next one, so sketch the parent graph of the equation. So our parent graph, remember, is f of x equals x squared. So this gives me 0, 1 squared is 1, negative 1 squared is 1, 2 squared is 4, negative 2 squared is 4. This is our parent graph of f of x equals x squared. Now, it says that our transformation is f of x, or y equals x minus 3 squared. I could do a couple things here. I could change it to standard form and graph it that way. I could remember that this is technically in vertex form, right, where I have 3, 0, h is 3, remember we don't include the minus sign, k is 0, and graph it that way. And just remember that, and then find other points here. Or if I recognize, hey, this is a translation, okay? And h, here's h is equal to 3, so this says, hey, take your graph and move it 3 units to the right. So move each of your points 3 units to the right. So if I was at 0, I'd now be at 3. If I was at 1, I would now be at 4. 2, I'd be at 5. Nothing else changes from the graph. Negative 1, I would be at 2. Negative 2, I would be at 1. Again, I have the same shape, same size. The only thing that's different is the location. Again, so looking here, we're not starting with the parent graph necessarily. F of x is x squared, or is x plus 1. All right? So if I'm looking here, my h is negative 1. My k is 0. So I know my vertex is going to be at negative 1, 0. All right. And if I recognize that this is a translation from the parent graph, everything would just be shifted over 1. But I could also do this. I could also just take the values that are before it, right? So I know that h is negative. I know that my vertex is negative 1, 0. We established that. So negative 1, 0. And if I take 2 points that come before that, that would be negative 2 and negative 3. Take 2 points that come after, that's 0 and 1. I put in 0, that's 0 plus 1, that's 1. 1 squared is 1. Put in 1, 1 plus 1 is 2, 2 squared is 4. So I've got my other points here. So I've got negative 1, 0, I've got negative 2, 1, I've got negative 3, 4, I've got 0, 1, and I've got 1, 4. There's my parabola here. Okay, so look at this one, and we see that from that to g of x, it changed. All right, so now for g of x, we have our vertex is at positive 3 and positive 1. So we've got a vertex at 3, 1. If I take my points, right, what are the values that are before 3? That would be 2 and 1. Guys, after 3 would be 4 and 5. I might just use 1 and 2. Those are a little bit easier numbers to use. Actually, I'm going to use 4 and 5 because if I use 1 and 2, I'm going to end up with negative numbers here, and I don't want that. So if I do 4 minus 3 squared plus 1, 4 minus 3 is 1. 1 squared is 1. Plus 1 is 2. So 4 is 2, which means 2 is 2. Which is the same thing for 5. 5 minus 3 squared plus 1. 5 minus 3 is 2. 2 squared is 4. And 4 plus 1 is 5. So I've got other points at, so I've got a point at 3, 1. I've got a point at 2, 2. And 4, 2. And I've got a point at 5, 5. And 1, 5. And if I look at the translation here, I know that it moved to the right 1, 2, 3, 4 units, and it moved up 1. So it moved to the right 4 and moved up 1. It moved to the right 4 and up 1 from the original graph that we started with. The longitudinal section of a canyon makes a parabola shape that has an equation of y equals 2 times x minus 3 squared minus 18, where x and y are measured in kilometers. If the depth of the canyon is 18 kilometers, how long is the distance between the two sides of the top of the canyon? It wants us to round our answer to the nearest tenth. So here, if I take my values, so if I put in 0 into my equation, so 2 0 minus 3, or x, I'm going to put my x minus 3 squared minus 18. I'm going to make a table so I can get my parabola shape on my graph. Okay, if I put in 0, this is going to give me 0 minus 3, so that's negative 3. Negative 3 squared is 9, times 2 is 18. 18 minus 18 is 0, so I have a point at 0, 0. I put in a value of 1. Again, I'm just getting my value here. Now, one thing I do know is that my vertex is at 3, because h is 3, and negative 18, because k is at negative 18. So I know that my vertex is 3, negative 18. So I want my points, again, on either side of the vertex. So we start with 0. That means that 6 is going to be 0 as well. Then I go to 1. 1 minus 3, which is negative 2 squared, times 2 minus 18. Negative 2 squared is 4. And 4 times 2 is 8 minus 18. That's negative 10. So I've got a value of 1, negative 10, which means that I also have a value of 5, negative 10. And then I've got negative 2, or 2. That's 2 minus 3. That's negative 1. Negative 1 squared is 1. Times 2 is 2. So 2 minus 18, that's negative 16. So here are my values. Now it should open up, because we're talking about a canyon. A canyon is an upward parallel, so I have a minimum here. So 0, 0, 1, negative 10, 2, negative 16, 3, negative 18, 4, negative 16, 5, negative 10, and 6, 0. Now I was asking how far apart is the canyon, the distance between the two sides of the canyon. Well, here's the top of the canyon, here's the other top of the canyon. How far apart is that? That is 6 kilometers apart. So they're 6 kilometers apart. This is how we translate quadratics.